This week we're going to look at factoring polynomials, and we're going to specifically look at one type of factoring, which is called greatest common factor. Okay, first thing we're going to do, we're going to look at some definitions, and the first definition we have here is polynomial. This is already on your note sheet. It says a polynomial is something that has numbers and variables separated by addition and subtraction. So it could be something as simple as x plus y, or 3x squared minus 7. Those are just some examples of polynomials. And some of them have special names. So for example, the first term that we have here, monomial, is a polynomial that just has one term. Now you're going to need to fill that in on your note sheet, something that has just one term. So something like an x or a y or combination of those, 9xy. These would all be examples of monomials. A polynomial that has two terms is called a binomial. Same thing, you need to fill that in on your note sheet. So this might be something like the example we used at the top, x plus y. Or the example we used at the top was 3x squared minus 7. Those are both binomials. And then a special polynomial that has three terms is called a trinomial. So this might be x plus y plus z. So something where you have three terms. What we're going to look at this week, or over the next several weeks, is we're actually going to factor these. And when you factor, that just means you're working backwards to find the factors of a polynomial. So for example, before the holiday break, we had something like 2x times the quantity of x plus 7. And what we were doing, we were multiplying this in. So we were distributing and getting 2x squared plus 14x. So what we're doing with factoring is we're actually going backwards. So we're going to start with the 2x squared plus 14x, and we're going to get this 2x times the quantity of x plus 7. So we're going backwards when we factor. And the type that we're going to look at this week is called the greatest common factor. And you've heard the term greatest common factor before. That's when you have the largest number and or the variables that all terms contain. Okay, the first thing that we're going to do when we factor, we're always going to start with greatest common factor. Regardless of which type of polynomial you have, you're going to start with greatest common factor. So let's look at a few examples. So the first example, we have 16m squared n plus 12mn squared. So the first thing we're going to do is we're going to figure out our greatest common factor. And to find that, we're going to look at our coefficients. So our coefficients are 16 and 12. So we want the biggest number that will go into both 16 and 12 evenly, which is 4. Then we're going to look at our variables and say which variable do they both have. So if we look, they both have an m. So we're going to write m, and then we're going to put the smallest exponent. So the first one has a 2, the second one has a 1. So m to the first. And then they both have a variable n. So we're going to put n, and we're going to put the smallest exponent. So n to the first, n to the second, so that would be n to the first. Then we're going to put a parenthesis, and we're going to put two blanks. Now to figure out the blanks, we're going to look at, for the first blank, we're going to look at the first term, and we're going to look at the greatest common factor, and we're going to divide these. So 16 divided by 4 is 4. Then we're going to subtract our exponents of our variables. So our m, we have 2m minus 1m, which would be m to the first. Then we're going to look at our n's. So we have a 1 minus 1, which is 0, so no n's there. Then to get the second blank, we're going to look at the second term, and we're going to divide that by the greatest common factor. So 12 divided by 4 is 3, and that's a positive 3, so we're going to say plus 3. We're going to subtract our exponents. So subtract the m's. 1 minus 1 is 0, so no m. And then subtract the n's. 2 minus 1 would leave us an n. Then this is your final answer, 4mn times the quantity of 4m plus 3n. Okay, let's look at example 2. So So example 2, same thing, start with the greatest common factor. So you'll look at your coefficients, which are 15 and 10. Your greatest common factor, so what's the biggest number that goes into both 15 and 10 evenly, which is 5. Then look at your variables. So the first one has an a, but the second one doesn't. But they both have b's. So we're going to put a b, and then we're going to take the smallest exponent. This one has a 2, this one has a 1, so b to the first. We have two terms, so we're going to put a parenthesis, and we're going to put two blanks. So to fill in the first blank, we're going to look at the first term, and we're going to divide it by your greatest common factor. So 15 divided by 5 is 3. We have an a, but we don't have an a down to divide it by, so we'll bring the a over, and then we'll subtract our exponents on our b's. So 2 minus 1 would give us 1b. Then for the second blank, we're going to look at the second term. We're going to divide it by the greatest common factor. So negative 10 divided by 5 is negative 2. Subtract the exponents on the b. So 1 minus 1 is 0. So no b's. So our final answer is 5b times the quantity of 3ab minus 2. Okay, let's try a few more examples. So example 3, we have 25a to the 4th plus 15a squared. So you're going to start with your greatest common factor. So you look at your coefficients first, so 25 and 15. So what's the biggest number that will go into 25 and 15 both evenly? And that would be 5. Then you look to see if there are any variables in common, and they both have a's. So we're going to put an a, but we're going to put the smallest a, which is a squared. Then we're going to draw a parenthesis, and since we have two terms, we're going to put two blanks. Now, we're going to figure out what this first term is. So we're going to look at the first term, and we're going to divide it by our greatest common factor. So 25 divided by 5 is 5. And then a to the 4th divided by a to the 2nd, we're going to subtract the exponents. So 4 minus 2 would be a to the 2nd. Then to get the second blank, we're going to look at the second term, and we're going to divide it by the greatest common factor. So 15 divided by 5 is 3, and that's a positive 3, so plus 3, subtract your exponents. So a squared minus a squared, so 2 minus 2 is 0, so no a's, and this is your final answer. Okay, and then example 4, start the same way. Start with your greatest common factor. So what's the biggest number that goes into 35 and 60 evenly? And I believe that's going to be 5. Look at your variables. They both have x's. So take the smallest x. So x to the 3rd and x to the 4th. So x to the 3rd is the smallest. They both have y's. So take the smallest, so we have a 4 there and a 1 there, so y to the 1st. That's your greatest common factor. Then a parenthesis, two terms, so two blanks. So to figure out this first blank, we're going to look at the first term, and we're going to divide it by this greatest common factor. So 35 divided by 5 is 7. X to the 3rd and x to the 3rd, so 3 minus 3 is 0, so no x's. Y to the 4th minus y to the 1st, so 4 minus 1 is y cubed. Then to get the second blank, we're going to look at the second term, divide it by the greatest common factor. So negative 60 divided by 5 is negative 12. Subtract your x's. So 4 minus 3 would be 1x. Subtract your y's. 1 minus 1 is 0, so no y's. So this is your final answer, 5x cubed y times the quantity of 7y cubed minus 12x. Okay, the next two problems, I want you to pause the video, I want you to try them on your own, then I want you to come back and watch and see if you have them completed correctly. So example 5, we have 3mn minus 27n squared. So once again, you're going to start with greatest common factor. So let's start with our coefficients, which are 3 and 27. So you want the greatest common factor, the biggest number that goes into both 3 and 27 evenly, which is 3. Then you're going to look at your variables, and you want the variable that they have in common. So if you look, the first one has an m, the second one does not, but they both have the variable n. So we're going to take the smallest n, so we have an n1 and into the second, which is n. Then we're going to put a parenthesis, and since we have two terms, we're going to put two blanks. Now, we're going to figure out this first term. So you're going to look at the first term and divide it by your greatest common factor. So 3 divided by 3 is 1. Then you're going to subtract your exponents from your variables. So the first term has 1m. The greatest common factor does not have an m. So 1 minus 0 is 1. Then you're going to subtract your n's. So 1n minus 1n is 0. Then we're going to find the second blank. So you're going to look at the second term and divide it by the greatest common factor. So negative 27 divided by 3 is negative 9. Then you're going to subtract your n's. So we have 2n's minus 1n is 1n. Then that should be our final answer. So 3n times the quantity of 1m minus 9n. So let's look at the second one. Example number 6, we have 20x squared minus 24xy squared. So start with your greatest common factor for your coefficients. So the biggest number that will go into 20 and 24 evenly, which will be 4. Then look at your variables and find your variables that you have in common. So they both have an x. So we're going to take the smallest x. So this first term is 2, second one's 1, so just 1x. And the second term has a y, but the first one does not. So we're going to draw our parenthesis, 2 terms, so 2 blanks. So we're going to fill in this first blank. So we're going to look at the first term, divide it by the greatest common factor. So 20 divided by 4 is 5. They both have x's, so we'll subtract our exponents. So 2 minus 1 gives us 1x. Then we're going to go to the second blank. We'll take the second term, divide it by the greatest common factor. So negative 24 divided by 4 is negative 6. Subtract your exponents. So 1x minus 1x is 0. So no x's left. You have 2 y's. You don't have any y's to subtract. So y to the second. So our final answer is 4x times the quantity of 5x minus 6y squared.
Hello, guess who this is? It's me, Owen.